Hello everyone. In this video we will learn how to create parts with arbitrary shapes both for door and product development. You might need to cut a triangle shaped part for a fancy furniture design, or a door model might need to have mitred corners. Therefore, arbitrary shaped parts must be producible both in door as well as product design. In adekoCAM door and product design environment, we create part shape either by make part shape or make part commands. You must be familiar with these commands by now. These functions create by default a rectangle as the part shape.
However, this happens only when they are not passed explicitly a polygon.
In case we provide a closed polyline, or in other words a polygon, convex or concave, they make this polygon the part shape. In this video we will create an L-shaped side part for a wardrobe with a notch and a rounded corner part usually needed in many door models. Let's start with the L-shaped part. I will work on the empty model. We will create a polygon and pass it to make part shape command.
Starting from one of the points, say the point at 0, 0, the other points are as follows. 0y is the next point, xy would be the top right corner. Let's call these edge lengths A and B, so we first declare them, and then the next point would be x, y minus b, because the width of the part is x and the length of it or height is y. A, y minus b is the next one. And the last point before closing the polygon would be A0, and then we close the polygon with 0, 0.
Let's run the model and see that it works. As you can see, the part shape is not anymore a rectangle. Another example is a part with rounded corners. Assume we want to have a part shape as you see on the screen, where the corners are formed by circular arcs. These arcs are usually lines with a bulge, which is a factor defining how much curvature the line will have. In CAD/CAM realm, a point does not only have coordinates in 3 dimensions like x, y, and z, but also the bulge parameter. The bulge of a point means how to go from that point to the next. Assume we are drawing a line from point A to point B. If the bulge of the point A is 0, the line we draw between A and B is straight, and as the bulge increases from 0, the line starts to curve. The direction of the curvature depends on the sign of the bulge according to the clock. Positive bulge values cause the line to curve clockwise and vice versa. Let's form the polyline, but before, let's first define these 2 parameters we will be using in the polyline for convenience. The first is the bulge parameter, and the second is the distance from the edges. Let me pick D0 as the starting point. The bulge of this point would be 0 as we are going to the next point straight. X minus D, 0, 0, B would be the second point. This point has the bulge because we are going from this point to the next one with a curve. Bulge is the 4th parameter. So to be able to set it, I need to enter also the z coordinate of the point, even though it is 0. XD is the 3rd point, and the bulge is 0 as we are drawing a straight line between this point and the next one. X, y minus d with a bulge is the next point, and the bulge parameter is non-zero because we are going from this point to the next point with a curve. And we continue like that. X minus d, y, no bulge, d, y, with bulge, 0, y minus d, no bulge, 0, d, with bulge, and d0 is also the first point closing the polygon. Let's run the model to have a look at how it looks. As you can see, the part has rounded corners. Let's experiment a bit. For example, change the bulge and see what it produces. Let's start with 0, and then continue with 0.2, 0.5, and minus 0.5. As you can see, different bulge parameters would produce different curvatures. In this video, we visited the method to create arbitrary length and shape parts. Thanks for your attention.